Hi and welcome to our next level 3 differentiation video. In this video we're going to show you some examples about graphing functions and their derived or gradient functions. Derived means gradient functions. Alright, here's the notation you are getting very comfortable with by now. Right, let's go back to a level 2 example just to get you warmed up. So here's a cubic function. And we know at these points we have minimum and maximum turning points, which are zero gradients. So we're going to drop those down to the line below, which represents on the x-axis a zero gradient. In this region, we know it's a positive gradient. Positive means above the x-axis, so we know the derived function is above the line. In this region, we have a negative gradient, which is below the x-axis, so we have a function below the x-axis. And in this region, we're back to being positive again, which is above the x-axis. So this is what our derived function or gradient function would look like. Also keep in mind that if it was a cubic, after we differentiate an x to the power of 3, we get x to the power of 2, which is a parabola. All right, well, we better get on to the level 3 stuff. This is a kind of question that could come up in your exam. Here's example 2. Draw the derived function, the gradient function. Right, it's a bizarre looking function and we have to draw what it looks like below. So let's get started. In this section of the graph, we have a zero gradient. Zero, it's a horizontal line, zero gradient. So all we need to do is draw it on the x-axis because the x-axis represents 0. Remember, above the x-axis is positive and below the x-axis is negative. Right, at that point, we're going to put an open circle because it's a sharp point. We are literally going from a zero gradient, leaping straight into a positive gradient. I don't know, it could be positive 5, positive 6. So we're leaping from 0 straight into a positive gradient. So we're going to have open circles and we're going to have a jump here. Right, what's going on in the next section? This is a weird part of the function. So let's see what's going on. It's this kind of line we're going to draw, and I'll show you why. In this first part of the graph, it's a positive gradient. So it is above the x-axis, which is positive, but eventually it gets back to a zero gradient. So it's positive, but it slows down and it gets to 0. And in this region, now we're a negative function, which is below the x-axis. Okay, what's going on here? We're jumping in the actual function, so what's going to happen in our derived function? Well, we're going from this gradient at that point, which is negative, and we're going to a positive gradient in this part. So we're leaping from a negative to positive gradient. So once again, we need a jump from negative gradient back up to positive gradient. Okay, in this part of the graph, we have a positive gradient and it's constant. It stays the same gradient for that section. So we've got a positive, which means we're above the x-axis, and it's a flat line that represents being the same gradient for the whole part of that region. Right, what's going on here? Well, once again, guess what we're doing? We're going from this gradient, which is positive, and we're going straight into negative at that one point. So there is no way we can differentiate that point. So once again, we need another jump. We're going from a positive gradient back down to a zero gradient. And finally, in this section here, we're back to being a zero gradient, which is a horizontal line. So we draw it on the x-axis at 0. All right, lot to take in there. You may wish to go back and watch the video a second time, but please go and find as many of these examples as you can because these are quite tricky and need a bit of work until you get more confident. Thanks for watching.